So let's look at the example that I have here. What does it do? It computes the matrix multiplication of two matrices A and B and assigns the result to variable C. Then it shows the content of the variable C. And finally, it also shows the transpose of the multiplication matrix. Although we have C, both f, printf, and disp functions, we will revisit them later in this lecture again. You can see that I have saved a function with the name multiplication script.m, and I can run that by writing the same name but without the m extensions in the command window. See that I needed to define matrices A and B before running the script, or the script will not know anything about such matrices. This tiny note will turn out to be very important. A script can see all the variables that are defined in the command window. A function cannot. We will discuss this again. For now, just see that when I was writing the script, I had assumed that two matrices A and B are defined ahead of time. So in the body of the script, I have simply written C equals A times B, and I was not worried about what A and B are. Later, before I run the script, I first define those two matrices in the command window. Now, when the script runs, it searches the memory for those variables and finds them and use them in its calculation. Alright, I have a very cool example here. It is about production plan for a manufacturing company. Assume the company produces 3 products indexed by 1, 2, and 3. We know the unit revenue of each of these products. Further, we assume that each type of the products has a fixed cost, which does not depend on the number of production of the product. For example, we know that once we decide to produce product 1, there will be a fixed cost of 40, and this cost does not depend on how many product 1 will be produced. Finally, we know that if we cannot sell a product, we have to pay some cost as the salvage cost to get rid of that product. This cost is computed per unit. So, for example, if I produce 7 products, 2, and then I can only sell 5 of them, I have 2 remaining product 2, which means I have to pay 2 times 3, or $6 as a salvage cost for this product. Now, how do I know how many products remain at the end? Well, that depends on the demand for each product, which is not known ahead of time. It is random, as you might expect, and we do not know anything about the demand at the time of manufacturing. That's why production planning problem is interesting. We do not know the demand, but we have to somehow come up with a product plan and finish the production ahead of time, before the actual demand is known. So in production planning problems, it is common to answer questions like this. If I know my production volume, then how much is my profit for a given value of demand? In this example, the demand is actually a vector with 3 elements, which shows the demand for each of the products 1, 2, or 3. Let's use the variable d for the demand vector, and let's use the variable x for the production vector. Consider this example if the production vectors is 20, 40, and 0, and if the demand becomes 25, 30, and 18. Then how much profit you may have made?